Welcome to the NVIDIA Omniverse live stream, everybody. I'm super excited. We have a very special guest. I won't show you who it is just yet, but in a minute, after we do some news announcements, you'll know her. But first, we're going to talk about some very exciting things that are happening right now. The NVIDIA Omniverse SDK 106, the beta, is available for people. There's a lot of really cool stuff in this release. Greater ease and control over your development workflows, packed with new tooling and enhanced functionality to accelerate the development of OpenUSD-based applications that are ready for cloud and on-prem deployment. You can check out that link there. I think Amelia, our producer, is going to be posting these links in the chat as we go over them. But developer.nvidia.com/omniverse. Super exciting. So that obviously that launch is imminent, but you can get a head start right now on things. And as I mentioned last week, we have the free and paid Omniverse OpenUSD training offerings. This live stream actually is a great complement to these OpenUSD training offerings that are available. We're going to post a link in the chat. We'll get more into the topic of today in just a minute, but very related to OpenUSD training and offerings. We also have a couple blog posts we'd love to get your eyes on if you can. We'll post these links in the chat. Robotic factory supercharge industrial digitalization as electronic makers adopt NVIDIA AI and Omniverse. Super exciting integrations happening. We want to share these stories to help inspire people and show others what's possible. If you have any questions on any of this stuff, please feel free to post in the comments live, or you can reach us on Discord afterwards. This is another complimentary blog on the NVIDIA robotics being adopted by industry leaders, tens of millions of AI-powered autonomous machines. We've been covering a lot of these topics on the live streams lately because we found out that through a recent poll, many members of our community are actually diving into robotics. So super exciting. That's one of the most popular items people are looking for. So be sure to check out this blog to get more insight. Here's another related one regarding Foxconn. And digital factories, digital twins, leveraging NVIDIA AI. Again, amazing insights on this blog. We hope you check them out, and feel free to share your thoughts on the Discord afterwards. We had SoftServe and Continental a few weeks ago on this live stream. Really a pleasure to have them diving into not only the background inspiration designs going into their collaborative work together, but how they actually put everything together, leveraging OpenUSD and generative AI. That's a fantastic live stream. We have a blog on it as well, so we'll post links to both. I highly recommend you check both out. Very insightful. Relating to this live stream focus today, which is officially titled OpenUSD 101 for Beginners. We're actually launching a great Learn OpenUSD. So we're going to have a link very shortly so that you can sign up to get notified. In the meantime, what we're asking people to do, this link should be available actually, probably by the time people watch this tomorrow, it'll be available, but within hours potentially. But for now, you could go ahead and hop over to the NVIDIA Omniverse Discord server. That's discord.gg/NVIDIA Omniverse. And we have an OpenUSD a forum topic there. And that's where the OpenUSD study group happens week to week, led by community member Nandu, who will be on the live stream in a couple weeks on June 26th. But we'd love for you to sign up to get notified as soon as this link's available. We'll put it in the Discord server. So definitely hop in there. And without further ado, it is my great honor and pleasure to bring over this young lady here, Jen Borucki, who everybody knows and loves. Jen, it's so great to have you back on the live streams. We've missed you. And Jen obviously is a staple of the community, has been working with developers throughout her career at NVIDIA. But let's dive into Jen's background first. So Jen, why don't you give yourself a nice introduction? Let us know your background actually and your focus here.
Oh, man. I have a long background. So I'll just keep it short. I like to make really cool things. So I like to do a lot of things, especially revolving around OpenUSD, and it's been such a pleasure working with some of the people internally as well as externally, and trying to really get a widespread adoption of OpenUSD, as well as how it works around within Omniverse. So yeah, I like compliment over there, just the triple threat of codes, teaches, and awesomeness. I don't know about awesomeness, but definitely codes and teaches. That's definitely a big one there.
Well, I think it's so great. So Jen obviously has been very active in our previous live stream, specifically with Ashley Goldstein on Learn With Me series, and also with Eric, or AKA Strainflow, on his Isaac focused live stream series. But Jen, so today, as I mentioned, this topic today is actually one of the purposes is to get feedback from our awesome community. That's why we wanted to kind of give everybody a preview of what's coming very shortly. And like I said, we're going to have a link so you can sign up for the exact announcement when it happens. But we have this great kind of, I would call it an expansion of what we have currently available on DLI relating to an introductory to OpenUSD. This series, Learn OpenUSD, dives into things a little bit deeper. And it doesn't require you to be a developer. It does go into some Python, as we'll talk about in a few minutes. However, this is really meant to give people kind of a better understanding of what OpenUSD and the different parts of it. And actually, and you don't even need to have or experience with or have Omniverse installed to be able to fool around with what we're going to show today, which is also awesome. But so since this involves kind of like teaching and the developer's journey on OpenUSD, do you want to tell everybody a little bit about kind of what your journey was as a developer and how you got to be where you are today as a developer, so that people have a little bit of context on where you're coming from?
Oh man, that's you're opening up a can of worms. So I'm gonna try to keep it.
I think it'd be great for people to know, right? Because then you have it might help some of the questions in the comments, which we invite everybody to be active in the chat.
I'll try to keep it short. I'll try to keep it short as possible. Fun fact, I actually did not think I would be a computer science major doing any kind of development. I thought I was going to be, PhD, biochemistry, and then I took organic chemistry and I said no more. So that was my kind of story and how I started getting into it. And then I started doing more in the mathematics type spaces, especially around stochastic processes, and trying to work in research where it combined. Actually, I worked a little bit with a professor back at Rutgers University around basically simulating like crowd simulation stuff, but how it would affect in dire or emergency situations. So we were essentially creating these kinds of digital twins and within Unity. So very early on, like back in like early 2010s. From there, I did a lot of teaching in terms of, Python, JavaScript, C++, C#. Like I went from different languages all the time. So if you wanted to know what a typical schedule would be for me on a daily basis, is you'd start your morning off in JavaScript, then you would go to Python, then you would go to Java, then you would go to C#, and then you would start doing game design and blueprints instead of Unreal Engine. So there's like this, and that was just on a single day. So I went through a lot of syntactical mistakes throughout the day, because I'd be coding in C++, and then my syntax would come up as Python. It was kind of a mess. So it's very nice to be in just Python now. And then from there, I kind of did a lot of like VR and XR stuff revolved around the medical industry specifically. And then on top of that, we were all under, and this is kind of where it a little bit relates, right? So we had 3D artists that we were trying to hire, and a lot of them, did not work in the legacy platform. So the platform that we used was 3ds Max. And we had a hard time hiring somebody who had 3ds Max experience. And this was about 2 years ago, right? So this is not like, 10 years ago kind of thing. This is a very relevant issue that came about in a small company that I worked at. And essentially, we were getting Maya developers and Blender developers and Cinema 4D people who were joining our team who had no idea how to work in 3ds Max. And so we were trying to look into using Omniverse and OpenUSD. And then that's kind of where I started to get into it. It was a really steep learning curve for me. And I still wholeheartedly believe that it can be a steep learning curve if you haven't seen it before. But working with, Maddie and Aaron and everybody at NVIDIA has really like elevated my understanding of USD, but unfortunately that's all internal. So I've been trying to work on making something more public that everybody can actually start getting used to, and really diving into this, because it's so much more powerful than you think it is.
Yeah,
But that's
yeah.
kind of like how the whole journey kind of
That's
goes.
perfect. That's perfect, which is why people want to watch the great live stream last week we did with Jen and Aaron Luke, going over kind of OpenUSD fundamentals. You can see why we have Jen back on here today, with her background and expertise. So as Jen just mentioned, she and the team have been working on what we're calling a learning journey. Learn OpenUSD, and I think hot off the presses, I spoke too soon. The link is actually live. So we're going to show this on the screen. It's in the chat already. Thanks, Amelia and Krista and Greer from the team for getting this ready for everybody today. So there is the link to be notified as soon as this journey goes live. What we wanted to do is give a nice preview today of all the content, for two reasons. One, we want to get your feedback. And if you notice anything that you think should be there that's missing, or you want to or would like us to dive into more something more specifically, this is a great opportunity. And we also just want to give everybody, our great fans out there, just a great sneak peek about what's coming. And the team is working very hard to finalize this up. And we should probably say it's multiple levels, right? So there's kind of the 101, and then there's the 200 series, or the advanced. We're gonna, on this live stream today, we're gonna go over kind of the basics, right? The 101 stuff, the fundamentals. And again, this is not just for developers, so don't worry if you're not a developer. I'm not a developer, so I'm in that category, and for, I think there's going to be great stuff takeaway for developers, non-developers alike. We had a great time kind of preparing this live stream today. So Jennifer has got some great things planned. So I'm going to share your screen, Jen, if you're ready.
Well, I mean, before that, let's kind of like
Yeah.
high level
Yeah.
first, so people get an understanding of how this journey works. I don't know. Do you have that slide up
Let
by
me
chance?
pull it up. Why don't you give it a quick intro, and I'll pull it up now.
Yeah. So I want to kind of some of you have been to GTC and SIGGRAPH, where we have taught some type of USD learning courses, and I really want to kind of like demystify what this is and how it differs from the other tutorials that we have done in the past. So essentially, the previous tutorials that you guys have been a part has a little bit of Omniverse combined with it. So for this course, we're trying to be very pure vanilla OpenUSD. So, if you were seeing like, the scene manipulator with USD, or, creating scene authoring tools with USD, some of that has USD in it, but it still has some Omniverse related stuff. There's also a course that does do some basic USD related content with some integrated, some Python snippets, but it doesn't go too much in depth, right? So our goal for this is to lay out that foundations for you, to lay out what are some of these concepts, what are these terms, and then how do you implement these, concepts and stuff. And then from there, we kind of get into that specialized workflow. So we're trying to really build out that foundation level for you, tell you how you can apply those. And then from there, then you can start talking about your specialized workflows, such as robotics or factory planning or media and entertainment, right? Like each one is going to have their own use cases around there. So for today, though, we're going to be mostly looking at a lot of the foundational stuff, where we're trying to basically show you what, some of these terms mean, as well as, what the best practices are for this. Now, unfortunately, I do not have any of the lecture series or the other stuff that's being built by the rest of the team, and they're working really hard and tirelessly just to get this out. Right today, I'll be showing you mostly the activity sides of it, which is going to involve a lot of Jupyter notebooks and Python snippets. And as Edmar mentioned before, if you're wondering, can I do these on my own? You most certainly can. You don't need to install Omniverse. You don't need to install, you do need to install the USD core libraries through Python, but all the stuff I will be showing, you should be able to have access to, except for maybe like one or two things, which aren't necessarily too important for you to get started. But it is something that we will be covering, and I wanted to do that. So again, so this is a preview. There might be some bugs that get shown. So if you're thinking, is this a 100% like I can take all this stuff and you're telling me for word that this is going to work, but we're still working on it. So just a disclaimer, note that there might be some issues that come up during this live stream. And if it is, you know what? Great. Let's debug it together, and then we can finally get Edmar to do some coding.
That would be awesome. And let me actually also add, so when you mentioned Jupyter Notebook, for people who might not be familiar with that platform, because it could sound like, a laptop. What is the Jupyter Notebook platform? You're muted.
Yeah, my bad. Sorry. So the Jupyter platform, so the Jupyter Notebooks are, it's hard for me to describe. So essentially, it's kind of like if you have individual Python scripts and markdown files, but in one singular notebook. So you can run things individually from each other. It's used a lot in data science, for collecting data and running certain types of snippets. And I thought it was a really great functionality to kind of expose and use, because you're not leaving the area when you're learning this content. I know that people who are going back and forth, especially if you don't have two monitors, going from VS Code to Google or your browser and back and forth, and maybe you have a PDF open, and then you try doing the split screen, but then your monitor is, this tiny little box. It's just not a fun experience. So this kind of like captures everything in one. And plus the best part about it is that you don't necessarily have to have Python installed. Jupyter also provides a way for you to try it online. But if you didn't want to run it offline, localhost, you would have to have Python installed, and then you would need to just do like a pip install for Jupyter. So there's different ways that you can do it, and it's very accessible. And I don't know, I've loved it for the past 5 years.
That's awesome. Here's a great little quick soundbite on what it is from Zia. Notebooks allow us to run and test Python code interactively.
Yes.
That sums it up very nicely. We also got an earlier comment from Lucky Rodriguez. I love being at the bleeding edge of technology. Things will break. How is the best part. Totally true. So, all right. So that is fantastic. Are we ready to move to the Jupyter Notebook?
Oh, absolutely.
All right.
Absolutely.
Let's do this.
So I'm running Jupyter through Python right now. So I'm not using Jupyter's live web integration. So this is all running locally on my machine. So I have a couple notebooks. We might not be able to get through all of them, but I did wanted to kind of show you guys some of them. But also, since I might not have enough time to go through all of them, I want to make sure that we go through the 101, which is essentially a flavor of all of them. So, oh yeah, that's a good point too, that, you can use this with Macs. You are not limited to only your Windows or Linux machines. Macs are also included.
And that, of course, is from NVIDIA's Ashley Goldstein. Hey, thanks for watching, Ashley. Okay, and here's a good question, actually, before we dive in. We talked about this a little bit in the warm-up yesterday, but would viewers have access to these notebooks?
You will have access to as soon as the courses go live. And so if you sign up for that link that was displayed earlier, I don't know if we can quickly show it off again. Yeah, that one. You will have access to them. Again, these notebooks, as of right now, are still in production. I just had permission to give a sneak preview of them. So, I'm giving you guys a little bit of a special thing. But again, everything that I'm showing, you can also run directly at home on your machines as well. So don't think that, you're limited to, I need to wait for the notebooks to be released. You can take these snippets and actually run them as well.
And you won't have to wait too long. I think the team's making a lot of progress. Yeah. Things are happening pretty quickly. So we're not talking about a year or anything like that. Like, we're talking much shorter time frame.
Yeah, definitely much shorter time frame. And I'm really hoping that we can get them put out. Cool. All right. So again, I'll be kind of going through this 101 module. If anybody had any questions as I kind of go through or has any feedback, I'd be more than happy to take it. But essentially, we're going to start our embark on our journey here through doing a couple different things. We're first going to show how we can create and manipulate USD files. We're going to define primitives in our scene. We're going to establish scene hierarchies. We're going to light up our scene using the USD Lux. Then we're going to be managing attributes and metadata, traversing and inspecting your USD files, and then we're going to verify your prim's existence. So in each notebook, what we have is a visualizer that goes with it. This visualizer is built by some of our team members internally. This is the only thing that would pretty much be missing if you were to run some of this stuff locally. However, if you go and download or compile the OpenUSD's libraries, you can use USD View to view these. So each notebook has this setup that goes with it. Actually, if you don't run them, then you won't be able to do a display. So I'm going to go ahead and run that. The first part, if you are trying to get a grip on how can I get started or create my USD files, in Python specifically, we have a couple different functions to do this. And a lot of the ones that we're going to be using are going to be coming from the stage class, which the stage refers to your top level USD file. And it's essentially your container for organizing a hierarchy of your elements, which are prims. So they're also not just limited to files, but they also, unify some scene graph with multiple different types of data sources, and we call those layers. We won't get into layers today. That's going to be a little bit further down, but I did want to introduce that there are three functions that we will be using for these notebooks that you might see a lot of. So first and foremost, there is the USD stage.create new. And the create new function essentially creates an empty USD stage where you can actually start assembling all your 3D scenes in. We have the open function, which is used to open an existing USD file. Then you have your save, which saves out your stage. So any edits you make in your stage, if you don't run the save function, none of those edits are going to carry over. So for this snippet right here that we have is essentially your basics for defining a USD stage. Now, this here, so I'm going to go ahead and I'm going to copy and I'm going to paste this in here. So as I stated before, Jupyter Notebook, each cell can be run individually. So when I run this, you now are siloed into this little cell. And as you can see right now, we're currently only printing out the stage and exporting it out as a string. But I basically created a whole USD file in what, 1, 2, 3, 4 lines? No, technically 3 lines because the print doesn't count. So I don't know. I feel like that's like, wow, 3 lines of Python. But it's kind of boring, right? Like we don't really have too much in it. So for a lot of this course, we're using USDA. So what is USDA? So this is a type of file format that essentially is a human readable UTF-8 text. Most of the time when you're opening up different types of files like USD, USDC, those are going to be, crate file format where, you have this binary type data going on and you can't really read it, right? You try opening it up in like a notepad and it's got all this gibberish in here. So to make it easier for people, especially in the foundational level here, we try to keep it so it's in USDA so you can actually see what's going on. And we'll see later how it actually looks in the visuals as well, because it gets pretty cool. All right. So when we're defining prims to our stage, one of the ways that we can do it is using some of the schema-specific APIs that we have available. So in this case, I'm going to be essentially creating this cube. And how I define that is using the USD geom libraries. And from there, we're going to pass it our stage as well as the path that we're trying to associate it with. And then again, this is where the save comes back in, where we actually save it out. If you don't have this save and we essentially just use the USD geom cube, well, we're not going to have a scene. So just to give a high level overview of kind of what's going down in this code, we're putting in the appropriate USD libraries that we're using. So we're using USD geom. From there, we are creating our file path, so our USDA file. And then since we've already created it in the previous cell, we're just going to use that open function that we mentioned before. And then from there, we're going to define our cube, save our stage. And then this is going to be the functionality that you will not have access to. But here's an amazing sneak peek of what's going to happen. So when we're running this cell, we can now see that we have this, we're displaying our USD file within Jupyter Notebook. So you didn't have to open up any other applications at all for any of this. We also added functionality so you can see the USDA next to it as well. So it's pretty neat.
Actually had this tip I wanted to show a little earlier, just for people creating their stage. She highly recommends, you rename your first stage, your name and maybe awesome stage. And I guess that makes it just easier to know it's yours.
Mm-hmm. Oh yeah, for sure.
Yeah, so you don't need a separate viewport, which is awesome.
Nope. So this is super amazing. Again, this is still a work in progress, so you won't have access to this. But I mean, other than that, you can rotate it, you can take a look at it, you can also pan within the scene here. Is pretty cool. So hopefully this adds a little bit depth in terms of what's going on in the scenes. So, yep, pretty much covered that. So in terms of creating a hierarchy, we've only defined, if we turn to look at this USDA, we've only defined one prim in this whole scene right here. So we don't really have much of a hierarchy. There's only one prim in our stage. So in order to define that hierarchy, what we're going to do is we're going to be using, again, we're going to be using some of that USD geom APIs, schema-specific APIs. And we're going to define a couple of different things that maybe some users might not be familiar with, such as scope and xform. These are two different types of prims under the USD geom, where a xform is going to be your transformations. They're not necessarily have any type of display, but they do define those types of transformations and are really great to have as like a wrapper if you're trying to move things. And then you also have your scope, which is going to be your way of essentially grouping or kind of organizing your hierarchy. And how you organize your hierarchy is kind of up to you, right? If you want to put geometry scopes where all of your geometry objects are going to go under, you can do that. You also have if you wanted to do it for lights, you can also do that as well. Maybe you have one for floor layouts, or you have one for animals, or you can have one for AI copies of Edmar. One or the other, however you want to do it. So in terms of displaying a hierarchy though, so let's take a look from when I add this code into here. Because you might have noticed that we are also essentially, instead of just giving it a string for each one of these, we're also providing this other long type of code here where we have get path and append path. So we're creating this really long path. So what is a path? Path is going to be a way to describe a prim in namespace and how you would get to it. So I'm going to go ahead, I'm going to run this. And so now we can take a look at our USDA. So prior, In our previous section here, we had it just one prim in our scene. In this case now, we have 3 prims in our scene. And here, we've established that the cube is under this group transform, which is underneath our geometry scope. So that's how you create a hierarchy. I mean, I feel like it's as simple as that, right? You have your scope, which is probably going to be your parent or your root prim in this case. And then its child is group transform, and their child is box. So we didn't really affect too much what's going on in the scene, but it's a way to kind of really organize your information and data in this. So, just to repeat, the hierarchy we essentially created was our geometry, group transform, and our cube. And then just as a reiteration, our X form is going to be defining a transform. So that includes your translate, your rotation, your scale in the scene. Whereas your scope is going to be your simple container. Doesn't really hold any transformation data, but it does pass along that if you were to put an X form on top. And then a cube defines a rectilinear cube. I had to look that up last week because I did not hear that word before. All right, so we've been doing a lot of USD geom type prims. There's also other different types of schema-specific prims. Another one is USD Lux, which is used to provide some representation for lights and related components in your scene. So for here, we're going to be kind of just looking into 2 different types of prims that are underneath USD Lux, which are going to be your dome light and your distant light. And we're going to do that same methodology where you're getting the path and then you're appending that path. This is the most easiest and non-error way to kind of go about when you're trying to define or adding new prims. So from here, if I were going to go ahead and add this to our scene and run this, our hierarchy kind of got a little bit bigger. But in this case, our lights is not inside of our geometry scope at all. And the one bug that you might have noticed, and I will make sure that it does get addressed, is that this doesn't necessarily display. You won't see a difference between this scene and the scene prior. You can't really necessarily see the lights in this, but this is a way to kind of actually visually see how we're building out our hierarchy, that there's, not necessarily always going to be your final root prim, especially when you're making more complex scenes. So from there, as you know, our hierarchy has now changed, and we've also introduced our 2 different prims, which unfortunately I can't really show too much off. So nextly, what we have is we also have attributes. I know a lot of people really dive deep into attributes. I know it's been covered a lot in different types of videos that we have there. I know Ashley's been working in attributes, Eric's worked in attributes, and even Maddie, when he was on, did a lot in attributes as well. And it is essentially your most common type of property, which is authored in most USD scenes. These are used to describe prims and how they should be represented within USD. So I've given one example here where we have a cube, which kind of goes back to what we've made before. But in this case, we've authored a property called weight, and we've assigned it a value of 50. So we've authored this attribute to be a part of cube. So it describes cube. So for this, we're going to essentially play around with some of the schema-specific attributes. So each schema-specific, so like USD Geom and USD Lux, they all have ways to retrieve attributes that they've defined in their schemas. If we're talking about custom attributes, that's a little bit different. They're not going to have their own functions for those because it wasn't defined in the schema. So in this case, we're actually going to be taking a look at how we can change the display color attribute using the USD Geom's schema for that. So just a little bit of a rundown for what this code is doing right now. So we have our cube where we're retrieving it from the scene, which I don't think we've covered this, but we have this get prim at path, which essentially retrieves a prim from the path provided. From there, if you're wondering what type of schema attributes are associated with a particular prim, there is a function for that. And you can print all those attributes out. So we're going to actually take a look and see what those are.
We have a good question from Zia.
Yeah.
Are attributes variables?
Sounds like, okay, so attributes are variables. You can relate them to variables, but attributes are attributes. If we're gonna stick with the language, they can look similar to that. So it's tough because you'll see some, later on concepts like primvars or different types of inputs, especially when you start getting into like materials and higher level geometry type concepts. So you can use it as kind of like okay, they're very similar. I wouldn't call them exactly the same.
Data Juggler's saying that a good way to think of them is its properties.
Yes. Essentially, attributes are properties, and properties are both attributes and relationships. But yeah.
Okay, we have another question that I wanted to circle back to because I think
Sure.
other people might be thinking the same thing. This is from Renan in the community. How do you display the Python code on the notebook? Then he goes on to say, have rendering and all, but I never got to display side by side the render and the code.
Oh, sorry, that's Phil's secret. I can't give it away. I'm sorry. He's got some tricks up his sleeve, and I don't want to really, reveal how that's being
All
done.
right. Fair enough.
Just know that he worked really hard on it. You're just gonna have to do some digging there. Okay. So now, so that's a way that you can actually go and display any schema specific attributes from there, and they're going to actually have a very particular way of getting those attributes. Because like, let's say you print out all these attributes and you're like, well, how do I know what function to use? Well, they have a kind of this formula they use where they start with a get and then the name of the attribute, and then they have the adder at the end. 99% of the time, you're probably right on that. And if you're not too sure, you can always go into OpenUSD's API docs, and they can also have it as well. But essentially, what we're doing here is we're setting the color or the display color of this cube to red, because it follows a RGB value. So let's go ahead and let's run this cell. And essentially, so if we take a look at what some of the schema-specific attributes that printed out, so there's a couple here. We have visibility, purpose, xform op order, extent. We have two primvars here. One's display color and opacity, double-sided, orientation, size, and another extent. That's interesting. But now you can see that our USDA file has now updated to include our authored attribute in here. So this is what we call an opinion. We have essentially created an opinion on this cube stating that its display color is now red. And that's, I mean, we've now made a red cube. If you are red colorblind, I'm sorry. This might look a little gray to you. If you're colorblind in general, you might have noticed that it got a little bit darker. But I guarantee to you that this is a red cube. I think I do want to address Zia's question about what is purpose. So for that, we don't go over purpose here, but just note that it can be, you'll just have to stay tuned. I don't know if I'm going to give an answer right now for that. You'll have to stay tuned. Sign up.
So again, anyone who's jumping in after the introduction, we are giving a preview of the learning journey called Learn OpenUSD, which is in development and will be available soon. We posted a link in the chat earlier, and we'll add to the description how to be notified when this learning journey is live. But Jen's going through, and I think, like, I don't know how much time we have. You have, Jen, but we're definitely going to go over here, which is great if you have time, because you've got so many good things planned here. I don't want to.
Oh yeah, no, don't worry. We're almost done with this one, and I'm going to make sure I show another one that's really cool.
Okay, cool.
So like, I know exactly what the folks are looking for. But yeah, so we did a couple different things here in terms of, retrieving the attribute. And again, anytime you retrieve an attribute, you're only getting the object. You're not necessarily getting the value, or you're not being able to, set the value directly. So we have to use a set function for this. We didn't use the get here. However, we do use it here. So there's two different functions in USD attribute that allow you, once you've gotten the object, the attribute object, you can then use the get and setter functions to grab those values as well as set those values. Something that I always noticed as I was programming is I always went, oh, I can do get size attribute, or I can do get display color attribute, and that means I got the value. You just got the object. You did not get the value yet. So here's a great example that we use here for, and this is kind of like a nice side-by-side type of thing where we're also authoring a different type of attribute. So in this case, we're using the size attribute instead, and we're using our get functionality to get the current value of the cube at this moment. And then we're essentially just doubling the size of that. So I'm going to go ahead and I'm going to kind of run this. I apologize if I'm like skipping a couple different concepts, but I'm hoping that, you guys are able to kind of read along or pause the video later on for some of this stuff. But essentially now we're assigning, there's going to be two different geometries in here. And this is kind of our final USD file after we run the cell. We have two cubes. One is used as like a little bit of a, here's what it would look like normally if you just defined it. And then here's one over here that's double the size and is now also red, right? Something that I did gloss over is how we were able to set the translate for the smaller box here, which we actually used a very specific API for this, which is going to be your XForm Common API. This is great for when you're trying to set any type of transformation. So it's not just for translate, you can also do rotate and scale as well. It's very robust. It leads to less errors when you're trying to set those operations. So let me just make sure that I got a couple things. So two quick things though that we'll kind of do, and I do want to mention, is how you're able to traverse a USD file. We do have a whole section on traversing, but if you were to, start your USD journey, and especially if you're working in really small files, this is not recommended for complex scenes that have hundreds, maybe even more than 50 prims, that because this is traverse functionality is a depth first search function. So even if you had different layers in your scene, so like let's say you had, 5 layers, it's going to traverse through all 5 layers. It's not going to traverse in your current USD. It's going to go through all of them. So this is recommended if you're just starting and you're trying to like figure out how can you, see what's in your USD file. This is what you would use. Is essentially it's very small. You're looping through all of the prims that you get from this traverse functionality. Again, not recommended for those if you have complex scenes. In that case, you would go to USD prim range and using a lot of that functionality there for tree pruning and stuff. We won't get into it today, but for those that are just learning, this is a great way for you to display your hierarchy. So here we are essentially displaying what we have in this USDA here. And you might have noticed that it's not including all information. It's just including the path of your prim. There's no properties associated with it, just the path and where it is. And you can see here that it is doing a depth first search where it's going through all of geometry first. And then once it's done with geometry, it moves on to lights as well. So the last one that I think is super important just for this notebook, before I get into my last one, is whether or not a prim exists. I know that this has always been a popular question of, does it exist? Is it here? It says I have a null value or it's a none. And I know that there's been snippets thrown up in the air, like, can I just check or whatever? This is a for sure way that I've worked with it. It is Maddie approved so far. But we essentially kind of use, I should not do that. We use the some Python specific checkers here. And essentially we're checking to see, does geometry have a child called box? Now, you guys might all be thinking, yes, it does. But in this case, it does not exist. That is because getChild is doing the direct child. Let me go back up to this scene here. If you'll notice that box is actually a child of group transform, not geometry. So if we wanted to do a check for group transform, we can go ahead and we can actually change box to group transform here. And now it states that our prim does exist. And we also have a little tidbit down here that does that. And this is essentially just one lesson. We've just essentially went through one whole lesson and me lastly speed running through through the last part of it. But it's just a little bit of a sneak preview. I do want to give a little bit of time if anybody has any questions before I kind of go into some interesting, fun things at the end. And I just want to make sure that I have time. But if Edmar, if we need to, somebody's.
No, I wanted to say just out loud here, several comments coming in just saying how awesome this material is and how great a teacher you are, Jen. So thank you so much for giving her a preview of this. Really, really fantastic. I see Scott Dempsey from the community here, who actually just released a good video on the latest Isaac update on YouTube. We'll put that link in the chat in a second if people want to check it out. But yeah, Scott said, really good course, fantastic material. Very good. Another one kind of from Stephanie from the community. Great to see you, Stephanie. Glad to see the updates on this course from the last one from DLI. That was challenging for me since I'm not a developer. Looking forward to this. So this is perfect. Good question here from Ordinary Alan, a great member of the community as well. Do you know if USD Preview and Jupyter will support animation timeline scrubbing?
So, it's funny that you asked that, and I don't know if you were looking, but this was the notebook that I was going to show. So that kind of leads really good into this one.
He saw the animation.
Yeah. Yeah, so we have a small section here about animation. Unfortunately, just to kind of save on time, I won't go too in depth onto how some of this stuff works. But we do cover some things about time codes, as well as how you can essentially take your properties or attributes and give time sample or create time samples from those. So again, we have this setup cell that we run every time, which essentially creates that nice viewer for us. And from here, I'm going to make sure that we create our stage. So we do have some functionalities in here, which will end up creating our stages for you. So if you're trying to, we don't want to reiterate too many concepts to you, especially if you're looking for just an animation section or just a prim section. So this is a good example of how animation works. So we've essentially created this scene where our root is going to be world. We have a sphere and a backdrop here with a couple different authored attributes inside of here. Now, from here, this is kind of getting into some of the animation side of it, where we're talking about time code and how you would set different time codes on a prim, and also the metadata that gets associated with your USD scene. So you do need to specify what time code you have, in terms of how many seconds is your animation. Is your animation 30 seconds? Is it 60 seconds? Is it, and you can also specify different types of properties as well. Something I also didn't know in these notebooks is I tried doing something very similar to some other content where there's all these different links in here. So a lot of these links are going to take you to some of the APIs, references, documentation in OpenUSD. Also, all of the functions that get set also will take you directly to there as well. So if you wanted to learn a little bit more, that's the direction that we were trying to make sure to go. Because I know that there's a lot of the times where we don't have links and people are wondering, where in the documentation is this? I try to include as many links as possible for this. So I'm just going to go ahead. I'm going to state that this animation or this USD layer is essentially going to have a animation that goes from 1 to 60. This only sets our metadata for the USD file up top. It doesn't necessarily do any kind of animations at this point. Now what we're going to do is once that has been set, we're going to actually apply some of those values using time code. So when you're setting attribute values, you also have an option to set a time code to it. So you can think of almost like a time code as like a time stamp or like a frame and what value it should be at that time. So in our case, we got a different kinds of translations that are being set at various different times. So from here, I'm going to go ahead, I'm going to paste this into here. And now, as you can see, we have a cube that, or not a cube, we have a sphere that's going up and down in our scene. So can it do animations? Yes. Yes, it can. And I guess just for a little context here, as I said before, we did set different time codes for different values of the attribute. So you can see that we have one authored attribute, and it has established that its time samples are the ones that we've set before. So at time 1, this is what the translate will be. At time 30, this is the translate, and so forth. So the last one that I do want to make sure that everybody understands is it doesn't have to be applied to a single attribute. Let's say you have multiple different, attributes that you want to set time samples for. So we can also do the scale. So from here, now that we've established some translates here, we're gonna now do some scales at different times as well. And do note that I am correlating the same time codes that I do for translate into scale as well. And if we actually take a look at this animation, we now have a bouncing ball. I have also tried to, my coworkers, when trying to do this in some of our testing rounds, got really into it. And I would say they spent a little bit too long on this notebook than I wanted them to. But as you can see, we are doing a very simple animation where we're just taking a sphere, moving it up and down, and then we're also scaling it. If you're wondering, oh, can I use, different types of, complex animations like character rigging or other stuff like this? Again, this is a very foundational type of work. So if you're looking for more complex stuff, I would not recommend putting that in here. If you're also looking for more complex types of animations, because as you can see, the time codes and time samples are going to be very long, creating a very massive layer file. So your animation curve stuff is probably not the best for this. But there are other information from different AOUSD people regarding some of that. But I just want to leave you guys with at least something a little bit more cool than the 101. But as you can see, we have, you can see over here, I have plenty of different notebooks that go over many different topics. These are just two of the ones here. Again, we do ask you guys if you would like to sign up to get, more than just this. There are lessons and lectures that go with these activities. So please sign up if you can for our beta when it gets launched, so you're notified when this actually becomes live. Again, this is not going to take years. This is something that I'm hoping we can get out very, very, very soon. So please sign up with that link. Other than that, I'm going to leave it to Edmar for any other closing remarks. But
well, Jen, again, I have to say this is really fantastic presentation, and although this is just a sneak peek, I think people have a lot to be excited about and look forward to. Make sure everyone out there is interested. Well, first, two things. One, if this live stream was helpful to you, please like the video. It really helps add visibility to this content to other people. And if you like this content regularly, definitely subscribe so you get notified. That's both those things are super helpful. And then also, we also have another link I'll put in the screen here too for general USD information. We also have this OpenUSD page with additional resources. But definitely sign up for that to be notified when the course goes live with a learning journey. Great. And then we also have some amazing live streams coming up as well. Let me see. We have I'll post the link in our chat here, but I think I already did. So there you go. There it is. But next week we have SAP coming on, which should be pretty awesome. And then the following week we have Nadu from the community will be who also is leading the OpenUSD study group with great members of our community every single week. And I was going to mention, Jen, that's where people, if you have feedback, if this was, really on the mark, or if something was missing, or obviously we just went through just one notebook here, but if you want to put your feedback on the Discord server, we have a forum channel called OpenUSD, and that's where all the study group information is posted. But that would be a great place to kind of share your feedback on this, or just get in touch with me, and I'll pass it along to the team. Many people obviously have been involved in this work, but it's really awesome to see, Jen, you be able to present this in this way. I think it's really going to open the doors to many other people being able to understand and learn and work with OpenUSD. You just broke things down so wonderfully here, as evidenced by the numerous comments we've been seeing throughout this live stream.
So that means you're going to be able to code now, right?
Well, so now, I'll probably do. What I'll probably do is I'll talk to you about maybe a little side project, and I could show progress during little segments of upcoming live streams. But yeah, I'll be one of the first people to take the course with everybody else. So I'm gonna put my email in the form as soon as this live stream is over. And yeah, let's continue the dialogue going on the OpenUSD study group. I think we have current plans actually for Jen to come on to the study group soon to actually, I think once the course goes live, she'll go up there and kind of and run through the course with people live. So that could be great. People, again, a Discord server is discord.gg/NVIDIA Omniverse. I'll put this huge huge banner on the screen, so people don't forget the address. There you go. Pretty impossible to miss it when you have a banner like that, thanks to Wendy Graham, I think. There's Nandu. We would like to use these tours as part of our OpenUSD Tuesday 5 p.m. discussion on NVIDIA Omniverse Discord. There you go. All right. So thank you, Jen, so much for taking the time with us today. Really, really fantastic. Great preview. We look forward to everybody's feedback. We look forward to launching this. Big thanks again to Krista and Greer and Amelia and Stephanie and others on our side who helped put this content together. Of course, Ashley and Maddie. You can't go without mentioning those guys. So thank you all for putting this together.
And huge thanks to all of our OpenUSD experts at NVIDIA. I honestly would not be able to be doing this and showing this without them.
Yeah, Aaron Luke, who was just on last week, and you might want to catch that live stream. And a big thank you to the community, to everyone out there watching this. Thank you for being part of the community. This is, as Zia stated earlier, a lot of the work we do comes about because of requests and interest from the community. So you're very inspiring, motivating to us, and deciding what we're working on next. And I think Zia mentioned that Stephanie had mentioned earlier that the DLI course didn't quite fit the bill. So for those who feel the same way, I think there's a lot to get excited about. OpenUSD, the learning journey that's coming out soon. So thank you all very much for joining this live stream. I'll see you all next week when we have SAP with us. That's going to be really fantastic. Learn how leveraging OpenUSD and generative AI for their sales operations and software. It's going to be a lot to be inspired by next week. And of course, we'll be taking your questions live during that live stream. And then on the 26th, we will have Nandu on from the community to talk about how his company is leveraging OpenUSD and his learnings and insights from managing the OpenUSD study group. So OpenUSD everywhere. And actually, one more thing before we go. If Jen and I are both headed, not only do we coordinate our shirts today, but we're both going to be at SIGGRAPH later on this summer. So if you have plans to go to SIGGRAPH, we would love to find out sooner or later so that we can coordinate and keep you up to date on some of the great stuff we have planning for SIGGRAPH. And we're all very much looking forward to it. Hopefully we'll be able to see a bunch of you there live. That's about it for today. Thank you very much for joining us today. Thank you, Jen, again, for putting together this material. Fantastic. Lots to look forward to. I'm gonna hang up and get my email on that sign up list. Thanks, everybody.